Hello guys, this is Shubham Pandey introducing you to our microcontroller assignment, which is keyboard interfacing. My team members are Anesh, Purnendu, Anubhav and Mohan, and we are submitting this assignment to Professor Karthikeyan A. Now what basically keyboard interfacing is. So first of all we need to know what is keyboard. A keyboard is basically an input device to a computer. Now a keyboard are organized in a matrix of rows and columns. Okay. Now the CPU has to access both rows and columns through ports. Now there are two 8-bit ports and 8 cross 8 matrix of keys can be connected to a microprocessor. So basically two ports which are 8-bit ports and 8 cross 8 matrix of keys can be connected to a microprocessor, that is to a computer. Now when a key is pressed, a row and a column make a contact. Okay, so for a key to work, they should make contact, a row and a column. If it does not make contact, there is no connection made. The rest of the concept will be taught to you by my friends. I'll hand it over to them. Thank you.
My name is Anubhav with registration number 14BEC0373, and I'll be explaining you about the matrix keyboard connection to ports. Here we have a basic keyboard layout, and it's a 8x8 matrix available, so total of 16 keys available, with port 1 as output port and port 2 as input port. As you can see, VCC is connected with 4 resistors available, and 16 keys are available at total, with value starting from the top rightmost key as 0, and the left bottom is the F key. So 0 to 0 1 2 3 till it goes on till C D E F. And here you can see basically what happens is the CPU accesses both rows and columns through ports. Therefore, with two 8-bit ports and 8x8 matrix of keys can be connected to a microprocessor. So when a key is pressed, what happens is a row and a column, it makes a contact. And when no key is pressed, there is no connection between any of the rows and columns available. So it is a function of the microcontroller to scan the keyboards continuously, and as I've said, to detect a pressed key, the microcontroller grounds all rows by providing zeros to the output port. Then it reads the column, and if the data rate from the columns is 1 1 1 1, that means no key has been pressed, and this process continues until a key has been pressed. If one of the column bit has a 0, it means a key has been pressed. So a key press has occurred. So what happens is the microprocessor, it will check the rows now. After a key has been pressed, the microcontroller will go through the process of identifying the key. Starting with the top row, the microcontroller grounds the top row first, and it checks for the output. And if the data reads all once, it means no key has been pressed in that row. So it will go on to the next row. As you can see, if consider the case here D0, if no key has been pressed in D0, and so the output will be 1 1 1 1. And similarly, if it will go on to the next port. The next port is D1, and suppose a key press occurs here, so it will give a 0 output here. So that means the key has been pressed in that row. So this is how the keyboard interface.
I am Purnendu to lesson 14BC0849, and I'll be explaining the flowchart for keyboard interfacing with 8051. We start by grounding all rows and reading the columns to check for an open key. If no open key is found, we'll continue reading the columns until one is found. On finding an open key, we read all columns and check if all keys are down. If not, continue reading the columns. If yes, then we wait for debounce and read all columns again and check if all keys are down. If not, go back to reading all columns. If yes, then we ground the next row and check if all keys are down. If yes, then we find which key is pressed and return.
My name is Anesh, registration number 14BEC0400, and I would be explaining the working of the code. Initially, P2 is made as input port and P1 is made as output port. It is checked that all the initial bits for the input port is 1111. If not, then it is sent over to the over label. An over label checks if the input added is 1111 or not. If it is 1111, it is sent back to check to the K1 label, or else it will send back to the over one label. In over one label, it checks which row is activated, row 0, row 1, row 2, or row 3, using the CGNE command. After compare jump not equal, it goes to row 0. The row 0 label command changes the value of dptr and calls the find function. The find function checks the carry bit, and if 0, gets the ASCII code and calls the match command. What match command does is it takes the value from the from the ROM and sends to SBUF, which in turn shows the output as serial communication. Then this is the code for the delay command which we use for debouncing, and this finally we've added the values in our database which we call using row 1, row 2, row 0, or row 3. Now we'll compile and run the program. As we change the input bits, we can see the output in the serial port. Right now row 1 is activated and the input is 1110, so we are getting 0. Now we are getting 1, 2 and 3. We can change the command to row 1 and get the output as 4, 5, 6, 7. Similarly, we can do the same thing for row 3 and row 4. So that was the working of the keyboard.
Hello everyone, this is Mohan Garg. As we have already seen in the PPT about keyboard interfacing with an 8051 microcontroller, we'll now summarize by discussing about the major points. So keyboard is basically organized into a matrix of rows and columns, and the CPU accesses both rows and columns through ports. In an 8051 microcontroller, there are basically 4 ports of 8 bits, and so when a key is pressed, a row and a column make a contact, otherwise there is no connection between a row and a column. The rows are connected to an output port and columns are connected to an input port in a keyboard while interfacing it with a 8051 microcontroller. So the rows are initially grounded and the columns are all set to 1111. So to detect a pressed key, the microcontroller grounds all rows by providing 0 to the output latch, as we have already seen, and then it reads the column. If all the columns are 1 1, so basically it means that no key has been pressed and the keyboard continues till a key is pressed. If one of the column bit has a 0, this means that a key press has occurred. So while searching for a key press, all we have to do is start from row and check whether if there is a 0 present there or not. If there is no 0 present, that means we need to switch to next row. If there is a 0 present, then all we need to do is check in which column the 0 is present, and so the key corresponding to that row and column was pressed. So that was all. Thank you and have a nice day.